is automation nowadays plays important role in all kind of industries. The automation is the technique of making an apparatus, a process, or a system which operates automatically. An automation is the creation and application of technology to monitor and control the production and delivery the products and services. Recent days, we know that human beings are replaced by the usage of control system such as computers or robots and various information technologies for handling different process. This is an industry, and it is also being implemented in all kind of manufacturing and assembling industries like automobile, aerospace, oil and gas, electrical and electronic components. The speakers from academics and industries will be delivered briefly about this. I heartily welcome Dr. P. Parandaman, sir. He was taking the class basic, basic and introduction to automation, and then today afternoon session, Professor C. Palani, Design of Hydraulics and Pneumatic Circuits. Then tomorrow morning, Dr. R. Manigandan, Assistant Professor of Triple E Department, is a programmable and logic circuits. And then after that afternoon session, Dr. Suresh, DGM Operation JPM Group of Companies Hosur, will deliver the lecture for industrial automation. I hope that all the participants all enjoy the session and it may enrich your knowledge automation in industries. I once again welcome all. Wish you all the best. Presently, that first session started. That I hand over to Dr. Parandaman. Take that deliver the lecture for basic and introduction to automation. Thank you.
Once again, I welcome students. Is the slide is visible? Anyone can answer. Slide visible? Hello.
Yes, sir.
Okay, good. For the 2-day workshop automation, today I'm going to start about the basics of industrial automation, and then afternoon session, Professor Palani going to take the class for the guys. So today for this session, we're going to topics definition of automation, need of automation, then automation principle, automation strategies, what is industrial automation, then types of industrial automation, automation migration strategy, then mechatronics in automation, then application of mechatronics system. So for this, what is meant by automation? So automation is basically the delegation of human control functions to technical equipment aimed towards achieving higher productivity, superior quality of end product, energy and raw materials, improved safety in working conditions, and so on. Simply, we can say you have to avoid works. We go for all the functions using the machines. So that is called automation. So what purpose we go increase the productivity, then quality wise increase, then more energy, then reduce the raw materials, then improve the safety also. There are variety of automation types is there. Building automation, for example, lift, smoke detectors. So these are in the consider of under the building. Then official automation, for example, printers. Now it is clear. Is it okay?
Okay,
Yes,
sir.
sir.
Okay. For automation, we know for the example printers, cameras, then CCTV, likewise. Then scientific automation, we go for the launching of rockets. Then light automation, we know about the street solar lighting, then traffic light. So these are the traffic, these are the light automations. Then industrial automation, we for the automated bottle filling, then steel factories. So today's scenario, all the industries we go for the industry. So next, what is the need of automation? So to increase the labor productivity, reduce the labor cost, then mitigate the effect of labor shortages, reduce or remove routine manual and clerical tasks, and improve worker safety, improve product quality, then reduce manufacturing lead time, accomplish what can be done manually, avoid the high cost of not automating. So these are need to go for the automations. So mainly focus on the increase of the productivity and also reduce the labor cost and safety wise. So these are the main causes to change the automations. So what is the automation principle? Understand the existing process, input, output analysis, then value chain analysis, charting techniques and mathematical modeling, then simplify the process, reduce unnecessary steps and moves, and then automate the process. 10 strategies for automation and the production system, automation migration strategy. So these are the principle to for the automations. Then automation strategies, specialization of operations, then combined operations, simultaneous operations, then integration of operations, increased flexibility, improved material handling and sortage, online inspection, then process control and optimization, plant operations control. Then we know about the computer integrated manufacturing. So these are the strategies used in the automations. So what is industrial automation? So today we go for the n number of products we make at that, and also the shortage of workers. So that purpose we need to industrial automation. The industrial automation is everywhere, and it is difficult to imagine a production line without automation. Industrial automation uses control systems and equipment such as computer, software, and robots to perform tasks that were historically done manually. So everything it will be done in the computer, software, and robots. These systems operate automatically, significantly reducing the level of operator involvement and oversight required. So automation systems typically consist of feedback loops and a sensory program that automatically adjust operating conditions to meet the desired value based on real-time data. The technologies used in industrial automation have advanced significantly in recent years due to digitalization of manufacturing, especially with the industrial Internet of Things, opening up more and more opportunities for companies to take advantage of automation solutions. For the real example, we have as a mechanical engineer, we know about the lathe. So we have manually operated lathe differ from the it is having the CNC turning operations. For the turning process, for the manual lathe, each and every operation is individually go for the feed, speed, cut, tool changes. So it is everyone will have to in a manual work. In a CNC machine, once you put the program, so everything done in the machine also. So that is a automation. For industrial automation, the use of computerized or robot devices to complete manufacturing tasks. Everything based on the programmers. So, for example, we have the one plant. It will be all the work will be using by the controls. So we have the software, hardware. So it will be controlled by the control system. So this control system only working in the plant. So for the control system, nothing but it's having the two types of control: open loop and then closed loop. So for this automation, all the functions are in a closed loop. Feedback only. Every output will be feedback given the input. So based on the feedback only, it will be operate. So this automation migration strategy for the it is having the three phase. Phase one, nothing but if having the starting work unit, so it is having the every work will be manual workstations. So every process under the manual handlings. For the phase, we have the limitation of manual handling, then automated workstation. For the phase three, so all the process in the working under the automation. So no need of human work. So that is a so we having the more production for the graph. We have the phase three having the more productions. So we choose the automations. Is it clear? Audible?
Yes, sir, it is.
Students?
Sir, yes, sir, it is audible. Please admit, some students are waiting, sir.
Yeah, yeah. Just. Okay, thank you. So what are the automation systems? We have the periodic worker, then auto. So once we have to choose the programs likewise, so then it will be input to the computer. So it will be automatically working in the systems. So for example, automated tools, transfer lines, then automated assembly systems, then industrial robots, automated material handling and storage systems, automatic inspection systems for quality control. Then what are the types of automation? We have the three automation types. One is programmable automation, then flexible automation, and then fixed automation. So these are the three types of automation is there. So first we go for the fixed automation. This type of automation is also referred to as rigid or hard automations. Once the operations all are in a fixed places. As the names imply, this form of automation is flexible and is often used to execute respective tasks with dedicated equipment in order to improve production efficiency and throughput rates. Once a fixed automation solution is set up, it is challenging to modify the process or reconfigure the equipment. Fixed automation solutions are good for production that is consistent and stable over time and has high volume throughputs. Example of fixed automations are assembly lines in the automations. Sequence of processing operations is fixed to the equipment configuration. So every process in a fixed lines. So that is called fixed automation. For the auto, these are fixed example of fixed automation. What is the feature of this fixed automation? Suited to high production quantities, high initial investment for custom engineering. Hello, is it okay?
Sir, okay, sir.
Like for custom engineered equipment, then high production rates, then relatively inflexible in accommodating product variety. So it is having the simple example automobile industries. So this is every process in a fixed line. Then programmable automation. This type of automation is best for batches of products where the instructions for the automated system change over time depending on which product is being manufactured. So for these yes, it is a batch productions. So it is having a variety number of batches there. So which one is preferable? It will be work. So that is called a programmable. Uh, the control programs can be each batch with a given specification and the necessary processing task and the sequencing. So for previously we are fixed means once we are fixed it will be routine work is there. But here programmable automation it is having batch different batch work is there. It will change the program then work with that. So that is called programmable automation. This changeover process takes time as in most cases the equipment must also be reconfigured from batch to batch. Programmable automation is often used for medium volume, also be used for low or high volumes when economics are justified. Industrial robots are an example of programmable automation. So for that we need which one is preferable. So that only we have to program. Capability to change the sequence of operation through reprogram accommodate different product configurations. So what are the features in the programmable automation? Then high investment in programmable equipment, lower production rates than fixed automation, then flexible to deal with the variation and the change in the product configuration for batch production. So these are very important. So these are high investment program equipments. So these are typical feature and also lower production rates than fixed automation. So when the fixed automation is having the higher productions, so routine work is the increase the productivity, but the programmable automation it is a lower production rate. Why it is means we have change in the program, reprogram is there. It is a batch production. Which one is we need? So we have to change it the program. So that's why we need the these disadvantage of program automation. Then flexibility to deal with the variations and the change in the product configuration. More suitable for batch production. This is also very important. Programmable automation is suitable for the batch production. Physical setup and the part programming must be changed between the jobs. Then flexible automation. This is a very flexible. Whenever need, it will be. Which one is important? This system is often referred to as soft automation. It is similar to programmable automation in that it provides flexible for product changeovers. Which one is we need? It will be changes. It is not a batch product. Whenever we need, it will be changing the productions. So that is called flexible. The big advantage of flexible automation is that the product changeovers are conveyed via the control system quickly and automatically, eliminating the time required to reconfigure the equipment in between batches. CNC machines are an example of flexible automation. So for whenever need the what component we need to operate, we have to change the program, then you do the particular component. So that is the example for the flexible automation. Of changing over from the one job to the next with a little lost time between the jobs. Typical feature of the flexible automation means high investment for custom engineering system, then continuous production of variable mixes of products, medium product rates, then deal with the soft product variety. So it is having the three types of automation. One is fixed, then programmable, then flexible automation. Fixed means it is having the high rate of production. Program means it is a lower rate of production. Flexible means it is a moderate, medium production of rates. So what purpose is flexible means? It is a high investment for. So what is the need of this? We can choose it the flexible automation. And also continuous production of variable products. So come to the mechatronics system. Mechatronics nothing but we know about the mechatronics nothing but involvement of different engineering areas: mechanical, electrical, electronics, computer, and then control engineering. So together, put together, it is having the combination of the engineering field that is called mechatronics. Um, so what purpose we need? It is a IoT method, nothing but IoT. Uh, for each and every department is having the separate works, but each together we get the automation. That is called automation. Manually, mechanical components there, then computer program is there, then controlling process there, then software is there. So each and every, all the application in together, it is called as mechatronics. For example, this is a system, tool, computer, car. So all the fields are available here. So this is called as mechatronics. So in automation. So what is the importance in the automations? So first we go for the start from the uh, need of design, then design specifications, then feasibility study with the collection of information. We need to collect the information. So what are the information there? It will be design, constellation, then analysis, then design analysis optimization, design evaluation, then come to the prepare the documentation of the design, that is called CAD and CAE. Then go to the process planning. So from the process planning we have to the production planning, design and procurement of new tools, order materials, then what choose of the machines. Then comes the production, then quality control, packaging, shipping, marketing. So everything's done. So any it is having some difficult or improvement, back to the again input of the design needs. So any changes we means it go for the design needs. You have to change the design, then routine the repeated values work process. So that is the important mechatronics in automations. So what is the measurement systems? System nothing but is to do some work from the input given, then get the output. So that is called system. Measurement system, you have to measure the input quantity, come to the change the number of scales or values. So this is a measurement system. So for example, the digital thermometer, we have the thermocouple. It is a input of measuring the temperature, and come to the amplifier, then analog to digital display, come to the display in the how much temperature is there. It will be displaying the output. So this is a simple example for the mechatronics. Then control system, to control the output to some particular value or particular sequence of values. Input require temperature, central heating, output temperature at the set values. A difference between the open loop, closed loop. We have the control system having two types of control system. One is open loop and one is closed loop. Open loop nothing but whatever giving the input, it will be comes to the output values. But closed loop nothing but we have to set the limited values. So for expected values, if we are maximum, it will be feedback to the input. It will be controlled by the controlling unit, and then we expect in the output values. So that is called closed loop system. So difference between the open and the closed loop means for the open loop, it is having not using the feedback. Feedback is not there in the open loop, and also less accurate, simple in construction, optimization in control is not possible, and also easy maintenance, cost wise. For example, these are CD deck, digital thermometer. So these are under the open loop systems. For the closed loop system, compulsory closed loop means it is having the feedback system, and also more accurate and complicated in construction. Automation control is possible, and also difficult to maintain, cost wise more. For example, for the closed loop, automatic water level, and also automatic washing machine. So today's scenario, everything comes to the automatics. So automatic means it is having the feedback system. So that is also called as closed loop systems. So this is a open loop. If you are having the some input, it will comes to the output, having the based on the input systems. But closed loop, you are having the some input is given, so some process there, and get the output. It's output we need to constant values. If varying means it will give the feedback to input. So for this it will be control, then it will change to constant values. For example, temperature. We know the output is we need a constant temperature, but here input temperature is given. Some deviation it is comes to the uh, temperature will be variable for the output. Suddenly it will give the feedback to control system. So then it will be constant temperature. So that is called a closed loop system. So it is having the feedback devices. So basic elements of a closed loop system. For example, reference values there. Then it is comes to the error signal, correction unit, process, then controlled variable. So from this we have the feedback from the output for the measured values given to the control unit. So it will be come to the under process, then output we need to control variables. So these are the basic elements of a closed loop system: comparison element, control element, correction element, then process element, measurement. Various elements for controlling the room temperature. For example, we need the hot of the temperature we measure in the room. So for here the circuit input is the required temperature. So these are the comparison element. It may be maximum or minimum. Then on here, so electric power is come to the electric fire. So it will be firing the this chamber. So we have the temperature increasing in the output. So if we are having the more temperature, it will give the feedback to comparison element. Already we have the input reference element is the is that. If you are increasing the temperature, or it will be constant. What will we expect in the temperature? It will be obtained by the feedback. So once it will be accept, it will comes to the output. Otherwise, it will be changing the temperature range. So this is a closed loop system. So these are various elements for controlling the room temperature. These are controlled variable. Then reference value, comparison element, error signal, control unit, then process unit, measuring devices. For example, we go for the shaft speed control. This one motor is here, the one motor is there, and the shaft is here. So if you are rotating the shaft, control the speed. So already we know the measuring the speed of the shaft tachometer. So would provide the tachometer. It will be feedback to here control area. So that means the amplifier. Between the DC supplies there, amplifiers difference between the reference and feedback values. So what already we have the some reference values there. So if we, what is the tachometer measure the speed, it will refer for the reference. So both are same. It will be going the running the same speed. If increasing more, it will be feedback to amplifier. It will be reduce the power supply. Then motor will be reduce the speed. So this is a soft speed control system. And also come to the for example, water level controller. If you are having the tank filling the water, some limit will be reference point is there. Once the reaching the reference point the water, so automatically it comes the feedback to the valve. So suddenly valve is closed, the input water is stopped. So this closed feedback system. If closed means feedback. So for example, this is a water level. You see the image. It is having the float one is there. Hollow bulb float is there. So top portion on tap is there. Water is coming inside the tank. It will be raised that water at the reaching point. So once the ball is top the limit of the level, automatically give the feedback to the valve comes to the stop. So this is an example for automation water levels. So schematic diagram. Here the resistance is there. One for the tank having the float also. So for the float needle is in the resistance. So here, this is a tank. So this tank having the filling the water. Water is rising at the particular limit is coming to here. The float will be join the needle. So here the transducer is there. So once the limit is target is filled, that the level signal is come to the valve. Once reaching the limit, the flow to valve is closed. So automatically the tank is we think about the water level is full. So this is a simple system of automatic water level. Then these are the schematic diagram of washing machine. So system is washing machine system requirements, understanding of load sizes, receptacle to hold cloths, agitation of drum, ease of use, reliability, then low cost actuators, AC DC motors, then sensors. These are the elements to the washing machine. So washing machine we need some process. What is the process? We have in the water level and rinse of the drum and washing the drum, then exit the water process. So it is having the four parts. One is pump, valve, heater, and motor. So once the pump need to increase the water level, then if we are the washing drum having the reaching the water level, we will stop the water, and then we need the temperature. Measure the temperature, particular temperature only we need the washing machine. So when the reaching the temperature will be give the feedback to control unit, and then next process come to the drum open or close. So you have to make the speed also. If having the drum speed, so each and every operation having the changing the drum speed. Reaching the process, then it will be washing machine door open or close. So these are the process in the washing machine control systems. Similarly, engine management system, it is having different process. Is it audible, students? Is it audible? Hello.
Yes, sir, it is audible.
Sir, yes, sir, audible, sir.
Okay. For the engine management system, we have the different spark timing, air fuel mixture solenoid valves, then fuel injection valves, engine speed sensor, crankshaft position sensor, then spark timing feedback sensor, engine temperature sensor, throttle position sensor, mass air flow sensor. Everything will be in the automation systems. It becomes under the microprocessor. So we have the programs. It will be run the engine within the each process in the automatic. So that is called engine management system. Similarly, automatic camera. So in the old years, we are having the manual operations. Each and every will be manual. The film also having, but here everything will be done by the machine camera. Focus and clarity, everything will be done by the camera. So that is called automatic camera. Nowadays we see in the cameras it is having the functions film, shutter, close shutter. So everything done by the camera. So that is called automatic camera. Then mechatronic system in manufacturing applications. These are the different applications there. Micro factory and then macro factories. Micro factory is nothing but it is a small size of working desktop sized factory. Build small parts with a small factory. Greatly reduce space, energy, and materials. For the drilling also, it is having micro levels drilling. Then CNC bending machines. So it is having some parts you having to bend. So these are the some mechatronic system applications. Transportation side, we have the typical application: brake by wire system, steer by wire system, then integrated vehicle dynamics, camlex engines, integrated starter alternators, Then reliability is the applications of the, what is the advantage of the mechatronic system transporter means rereliability, reduced weight, fuel economy, manufacturing flexibility, design freedom, then advanced safety feature, cost wise. These are the advantages in the mechatronic system used in the transport applications. So these are the some another chance, high speed trains, then transportation applications for the system usages for the um, tilt and pressure sensors, microcontroller motors, onboard power sources. So then advanced is simple and intuitive personal transportation devices. So this is very simple construction for the transportation. Single person will be moved straight away. And smart robotics applications. If we are having the turret place, big dog robots, you have to carry the things in a turret place. And then medical application also, we have the leg, so everything in the uh, most of the medical application using the mechatronics. So arms, legs, and other body parts can be replaced with the electromechanical parts. And pacemaker, then implantable defibrillations. So these are using the medical application and also defense applications. We have the stealth bomber, unmanned aerial vehicle, UAV, and then we are using today this virus infection. We have to avoid the virus infection. Sanitation applications. System used as proximity sensor is used. Then control circuits we have. Then electromechanical valves there. Independent power sources are there. So for the advantages, reduce the spread of germs by making device hands free. Then reduce wastewater by automatically turning off when not in use. We have seen the high level hotels. We have just keep on the near to tap, automatically will flow the water. Then removing the hand will be stop the water by using the sensors. Similarly, sanitizer also it will be flow that. So next one is sanitation applications. So these are automatically we are seeing the mall. We go for the near to the paper towels dispenser. So automatically comes to the dispenser. So paper is come out, and also if you are remove that, it will stop it. Similarly, dispenser here also some soap washer is there. So these are the by using the sensor, it will be what need to go for the nearest machine. It will be giving the some sanitizers. So after removing the hand, it will be stop that. And also we are applying the sports application also. So these are the different parts is applying the mechatronic systems in the sports applications. Then smart robotics applications, vacuum floor, then cleans gutter. So you have to think about the new idea also. You have to think. So these are already exist about the new ideas using the smart robots. Then smoke detector also there. Then what function is available in the automations? Most use of the function is sensors. So each and every field having the sensors. We need the, for example, we practically visiting the television. We have some remote sensor is there. So everything you nowadays having the sensors. It may be humidity sensor or flex sensor, touch sensors, solar sensors, nothing but light sensor, then real-time clock sensors, then vibration sensors, thermistors, and then air sensor, IR, then then ultrasonic sensors, then gyroscope sensor, accelerometer sensor, then color sensor, PIR sensor, gas sensor, smoke sensor, temperature sensor, LED sensor, rain sensor. So everything is available now. So for the particular application, we choose the particular sensors. Now come to the industrial application machines. It is having the storage system, then handling systems, assembly lines, and then production lines. So these automations. Uh, where need to storage, you have to automatically it will be moved to the storage systems, and also handling one place to another place. We pick and place robot is available, and also assembly lines. Each part we have to assemble in a sequence of operation. We need the automations. So we have to actuators and sensors is there. Similarly, production lines also. So these are structure of industrial automation. We have the computer, then actuator, sensor, then software. In bit of these things, we have to complete the industrial automation. Some example for the industrial automation is having the machine. It is having different functions in a single time, in the simultaneously working the different operations. So for these car manufacturing company, example image, and then these assembly unit or welding, pick and place, example for the industrial automation images. Um, so here pick and place is there. So these are pick and place robots, and also machines, automation machines there. So these PLC, we are using that, and also 3D printing. So everything it will be comes to the automations. Scanner, and analyze the component. The realities of modern manufacturing, globalization. Once underdeveloped countries are becoming major players in manufacturing. International outsourcing part locally are now being made of offshore or near shore. Local outsourcing, use of suppliers locally to provide parts and services. More realities of modern manufacturing. Contract manufacturing, companies that specialize in manufacturing entire products and not just parts under contract to other companies. Trend towards the service sector, quality expectations, then customers, both consumer and corporate, demand products of the highest quality, need for operational efficiency. Manufacturers must in their operations to overcome the labor cost advantage of international competitors. So these are the more reality of modern manufacturing. So what product system defined? So we have two different products there. So for this production system is we need a collection of people, equipment, and procedures organized to accomplish the manufacturing operation of a company. If you're having a company, we have the different process there. We have to the equipment and the procedure we need to organize. So that is called a production system. So manufacturing support system and facilities, factory and equipments. Factory production machines and tooling, material handling equipment, inspection equipment, and a computer system that control the manufacturing operations. Manufacturing support system is having the business functions, product design, manufacturing control. So for these business functions, it's having sales and marketing and order entry, cost accounting, and customer billing. These are the business functions. For the product design, research and development, design engineering, prototype shop. So these are under the product design. For come to the manufacturing planning, you have to plan the process, production, and then MRP, capacity planning. So these are under the manufacturing planning. Come to the manufacturing control, we have to control the shop floor, inventory, and quality controls. So for this SIM, we know SIM, computer integrated manufacturing. Computer integrated manufacturing is combined together the design and the manufacturing. So we are having the production system and the design system. So it will comes to the put together. We get the computer integrated manufacturing. For small video for this. Just wait. You see the video.
Sir, some boys are waiting.
Video visible வருதா? Hello.
Yes, sir.
Just see the how to industry the automatics.
Yes, sir.
So everything will be in the automatic process. Rolling, cutting. No need of human work. Everything is done by the robots.
வீடியோ ஆஃப் பண்றது ஆஃப் பண்றா ஒண்ணுமே தெரியும் இரு
So this is the routine process. No need of human work. It will be repeated by the machines also. It will increase the productivity. Okay, so these are the main things in the automation. So automation, nothing but it have the reduce the human power, then increase the productivity. Uh, for the industrial automation, we have the three types. One is fixed, then programmable, and then flexible. Cover in the basic of industrial automation. Uh, if you are know about the industrial automation, we have the basic things. We have to need the software in the industrial automation. What are the hydraulic pneumatic drive is there. So for the afternoon session, we have the hydraulic and pneumatic drives session by Professor C. Palani. And then tomorrow we have the first session handled by Dr. R. Manigandan. The topic is programmable logic controller. And then after that, for the industrial person, how to implement in the industry. I think the session. Thank you all. So any doubt? Okay, thank you all. So any doubt? Yes, me. Otherwise, we can stop the session. Thank you all.
பேசியாச்சு இந்த 2 வாரத்துக்கு யாரும் வரக்கூடாதுல்ல.